All right, and homework 4.3b, this came from a textbook, so the setup, you need to do it on another piece of paper. I'll do one in each section, I think. This first one says to do the integral of various things, and this integral is the same as asking you what's the area between the x-axis and the curve. So I'll do 27. It's the integral from 0 to 2 of 2x plus 5. And so here's 5. Goes up by 2, over by 1. That's what it looks like. This is 7. This is 9. 1, 2. And we're supposed to find the integral, and that's this area right here. So what I would do is I would break this into a trapezoid, or I could break it into a rectangle plus a triangle. I'll do that. I'll do a rectangle plus a triangle. This is a rectangle with a length of 2 and a height of 5. So 2 times 5, this area is 10. And this triangle has a length of 2 and a height of 4. So it's 2 times 4 divided by 2. It's the base times the height divided by 2. And so this area is 4. And so the overall area, the integral from 0 to 2 of 2x plus 5 dx is equal to 10 plus 4, which is 14. So let's look at the next section. In this one, they give you a few integral values, and you need to use your properties of integrals. I will do, I guess, let's do number 38. 38 says the integral of from 2 to 4 of x cubed plus 4. That it's a little bit messy, the way to read it, but that's what it is. And this can be split into the integral from 2 to 4 of x cubed plus the integral from 2 to 4 of 4. So the integral from 2 to 4 of x cubed, it says right here, is 60. The integral from 2 to 4 of 4, well, that's one we need to do graphically. So the integral from 2 to 4 of 4, the line y equals 4 is a horizontal line. Here's 2, here's 4. And so we've got this area with a base of 2 and a height of 4. That's 8. And so the integral is 68. Here we had to mix the integral they gave us plus an integral of a geometric interpretation one like you did in the first section. All right. More properties. 41. I'll do 42 here. It says, given that the integral from a to 3 of f of x equals 4, and the integral from 3 to 6 of f of x is negative 1, evaluate, I'll do, I don't know, b. The integral from 6 to 3 of f of x, well, if it's going backwards, that's the same as the negative of the integral from 3 to 6. So instead of 6 to 3, I'm going to rewrite it as 3 to 6 of f of x, which is negative 1, which is positive 1. All right. The last one, we've got a graph. This actually comes up. There's graphs like this on every AP exam, and you have to be able to do the integrals of them. So I'll do, I guess, D. D says the integral from negative 4 to 6 of f of x, and so it's just the integral from negative 4 to 6. So that's the whole thing. So I've got this area. This is below the x-axis, so this is going to be a negative area. We've got a height of negative 1 and a base of 2, and it's a triangle. So we've got negative 1 times 2 divided by 2. That's the triangle. So that's got an area of negative 1. This is a semicircle. This is going to be pi r squared divided by 2 because it's half of a circle. The radius is 2, so it's pi times 2 squared divided by 2. This is going to be 2 pi plus, negative 2 pi because it's below the x-axis. Because it's below the x-axis, it's a negative area. And the last thing, we've got a triangle here with a base of 1, 2, 3, 4, and a height of 2. So it's going to be 4 times 2 divided by 2. This area is 4. And so we've got negative 1 minus 2 pi plus 4, which can simplify down to 3 minus 2 pi by combining these like terms. So that's kind of the strategy for how to do each of these. I hope that helps.